During this segment, we will review algebraic expressions and sets of numbers. Let's begin by a review of the word variable. Remember, letters that represent numbers are called variables. Also, let's talk about the definition of an algebraic expression. Numbers and variables connected by operations of addition, subtraction, multiplication, division, raising to powers, or taking roots. Those are called algebraic expressions. So this is an algebraic expression. AB is an algebraic expression. Remember, that means A times B. By the way, what does evaluate mean? Evaluate means find the value of. So let's evaluate, let's find the value of this algebraic expression when A is 1/2 and B is 3/4. So this algebraic expression, AB, which is A times B, it is when A is 1/2, I replace A with 1/2 times, I replace B with 3/4. And then to find the value of the expression, we multiply these two fractions. How do you multiply fractions? Numerator times numerator over denominator times denominator. So that is 1 times 3, or 3, over 2 times 4, or 8. 3 and 8 have no common factors, so it is in simplest form. The value of this expression, given these replacement values, is 3/8. Let's evaluate another expression. Let's look at the following. The B-737-400 aircraft costs $2,948 per hour to operate. The algebraic expression 2,948t gives the total cost to operate the aircraft for t hours. Find the total cost to operate the B-737-400 for 3 6/10 hours. So here is our algebraic expression. We want to then evaluate this algebraic expression when t is what value? We are given that. We want to know when the time is 3 6/10 hours, so when t is 3 6/10. So this 2948t, given this replacement value, is 2948. Now this is times t, so this will be times 3 6/10. And I'll let you do the multiplication, but once you do, you'll have 10,612 and 8/10. Now what does that mean? It means it costs $10,612.80 to run the aircraft for 3 6/10 hours. So that's a little bit about algebraic expressions. Now let's look at some common sets of numbers. First, let's start with the set of natural numbers. The natural numbers is a set consisting of 1, 2, 3, and then so on in the same manner. That's what the 3 dots mean afterwards. We next have the set of whole numbers. Notice the whole numbers start with 0, and then we have the natural numbers 1, 2, 3, and so on in the same manner. Then we have the set of integers. Now notice we have the 3 dots, the ellipsis, to the left of -3, which means in the negative sense this continues in the same manner. And then we have -3, -2, -1, 0, 1, 2, 3, again continuing on in the same manner, this time in the positive sense. Then we have the set of real numbers. We're using set builder notation here to describe the set of real numbers, and that is the set of all x, the set of all numbers x, such that x corresponds to a point on the number line. Rational numbers, the set of all numbers of the form a over b such that a and b are integers and b is not equal to 0. And then irrational numbers, the set of all numbers x such that x is a real number and x is not a rational number. So let's take the following written in set builder notation and let's actually write out the members of the set. Now, by the way, from our definition of rational numbers and irrational numbers, can you see that every real number then is either a rational number or an irrational number? There are no numbers that are both rational and irrational. But let's take this set written in set builder notation. This is the set of all numbers x such that x is a natural number less than 6. And let's actually write out the elements of this set. So to write out these elements, let's begin with our natural numbers. Do natural numbers begin with 1 or 0? Natural numbers begin with 1. So I have 1, 2, natural number less than 6, 3, 4, 5, less than 6, so I do not include 6. Here we have the set in set builder notation, and here we have the set with the elements listed. Let's now look at a set of real numbers. Let's take the set consisting of, say, 3, 0, square root of 7, square root of 36, let's see, 2/5, and let's put a negative number in there. All right, I have a set of various real numbers. Let's talk about which of these numbers are whole numbers. Which of these numbers are whole numbers? Well, certainly 3 is a whole number, so 3 I'll list. What about 0? Is 0 a whole number? The answer is yes. Remember, the natural numbers start with 1, the whole numbers start with 0, so 0 is certainly a whole number. What about the square root of 7? Actually, the square root of 7 is an irrational number. What about the square root of 36? The square root of 36 simplifies to 6, so this is actually another name for 6. Since it's another name for the whole number 6, we do list this among whole numbers. 2/5, that is not a whole number. Remember, the whole numbers consist of 0, 1, 2, 3, 4, 5, and so on. And what about negative 134? That is not a whole number. It's actually a negative integer. So here are our whole numbers. Now let's look at the use of the element symbol. For example, here I have the number negative 11. And then here I have the set of all numbers x such that x is an integer. I want to know, is this an element of this set or is it not? Now remember, here is our notation for is an element of, and that is not an element of. So let's replace this space with this symbol or this symbol. Is this an element of this set? Well, this is the set of integers. Negative 11 is an integer, so negative 11 is an element of this set. Now let's try this again. We're either placing this notation or this notation. All right, I'll write this underneath. I have the number 12. I want to know, is it an element of or is it not an element of this set? Now let's look at this set a moment. I'm listing the elements of this set, 1, 3, 5, and so on in the same manner. So how does this continue? 1, 3, 5, 7, 9, 11, 13, and so on. These are odd numbers. So is 12 an element of this set? The answer is no. It is not an element. So we use that notation to show that it is not an element. So that's a little bit about common sets of numbers. Next, we want to discuss absolute value. Now, if you have a number line, the absolute value of a number is that number's distance from 0 on the number line. So that's a number line description of absolute value, but let's look at a formal definition of absolute value. The absolute value of A, written as, and notice the two vertical bars about A, so it is the absolute value of A equals A if A is 0 or a positive number. And then the absolute value of A is negative A, or you might want to think of it as the opposite of A if A is a negative number. So let's simplify a few numerical expressions. Here I have the opposite of the absolute value of 2. Now be careful, this is outside the absolute value bars, so I simply rewrite that and now concentrate on the absolute value of 2. The absolute value of 2 is 2. Think of it in two ways. The distance 2 is from 0 on the number line is 2, or notice that from our formal definition of absolute value, this is a positive number, so the absolute value of a positive number is the number itself. So the opposite of the absolute value of 2 is the opposite of 2. Let's try that again. Let's evaluate the absolute value of negative 4. Now, the absolute value of negative 4, this is a negative number. Think of it in two ways. What is negative 4's distance from 0 on the number line? Negative 4's distance from 0 on the number line is 4. Now, by the way, from the definition, if we use the definition, it says the absolute value of a negative number is the opposite of that number. Well, what is the opposite? And we'll talk more about this in just a moment, but what is the opposite of negative 4? Well, the opposite of negative 4 lies on the opposite side from 0 as negative 4, but the same distance from 0. So the opposite of negative 4 is 4. Either way, you have 4, but this does show you one thing, and that is, in general, if you have some number A, the opposite of negative A is A. The opposite of negative 4 is 4. So there's our absolute value, though. The absolute value of negative 4 is 4. And then, by the way, what is the absolute value of 0? Let's make sure we clear that up. What is 0's distance from 0 on a number line? It is 0, or looking formally, if this number is a positive number or 0, the absolute value is that number itself. So the absolute value of 0 is 0. Now let's talk a little bit more about opposites. The opposite of a number, if you look at its graph, is the number that lies on the opposite side of 0, but the same distance from 0. So the opposite of 2 is negative 2. The opposite of negative 5 is 5, and so on. Let's find a few opposites. What is the opposite of negative 6 and 2/10. Think of negative 6 and 2/10 if you want to on a number line. There's negative 6 and 2/10 on a number line. What number lies on the opposite side of 0 but the same distance from 0? It would be positive 6 and 2/10. So the opposite of negative 6 and 2/10 is positive 6 and 2/10. We'll do one more example, but let's look at our definition of opposite. The opposite of a number A is the number negative A, or the opposite of A. So let's try that one more time. The opposite of, by the way, if you want to use that definition, the opposite of this number, if that's my number A, it is negative A. But what is that? That is 6 and 2/10, just as we wrote a moment ago. Let's find one more opposite, though. What does the opposite say of 4/7? All right, think of a number line. What is the opposite of 4/7? If you want to think of it, think of this as our number A, and the opposite of A is negative A. So the opposite of this is negative 4/7. Now let's practice writing phrases as algebraic expressions. In other words, I'd like to write this phrase, 10 less than a number, as an algebraic expression. I'll let x represent my unknown number. So 10 less than a number, is that 10 minus x or x minus 10? Because we must be careful with subtraction. Well, I'm taking 10 from a number, 10 less than a number, so it's our number minus 10. You might want to take a moment and study that example, and let's try another example. Let's translate this phrase to an algebraic expression. 12 minus 3 times a number. 12 minus, and then how do we represent 3 times a number? 3 times a number is 3 times x, or 3x. So 12 minus 3 times a number translates to 12 minus 3x. At this time, practice finding absolute values, practice finding opposites, and practice translating to algebraic expressions. Let's now take a moment and check your understanding of algebraic expressions by answering the following. If y is equal to negative 3, then negative y squared equals, is it choice A, the opposite, or negative, in parentheses, negative 3 squared? Is it choice B, the quantity negative 3 in parentheses squared? Or is it choice C, the opposite of negative 3 squared? The video will pause, then you take your time and then make your selection. Choice A is correct. Let's talk about why. Just be very careful here. We've rewritten this opposite of, or negative sign. Then y itself is negative 3. And since y is to be squared, to ensure that negative 3 is squared, it is placed within parentheses. Now, by the way, let's go ahead and evaluate this. You square negative 3, so that's negative 3 times negative 3, which is positive 9. But then you have to keep this rewritten, and so the result is actually negative 9. Choice A is the correct choice. Choice B is not correct. Let's talk about why. Here is the expression that we are evaluating. We've got this negative sign, and then y itself is negative 3 squared. So there should be a negative in front. That is not correct. the correct choice is A, which is the opposite of, and then y is negative 3 squared. By the way, how do we evaluate this? You square negative 3, so it's negative 3 times negative 3, which is positive 9. Then this is the opposite, which is then negative 9. Choice A is the correct choice. Choice C is incorrect. Let's talk about why. This is the opposite of, and then y itself is a negative number. The only way to ensure that y, which is negative 3, is squared is if this negative 3 is placed in parentheses. So C is incorrect. A is the correct choice. Now, by the way, how do we evaluate this? It is the square of negative 3, so it's negative 3 times negative 3, just as this asked for, which is 9, and then it's the opposite of 9, or negative 9. A is the correct choice.